This video is a part of lecture video series for third semester students. This lecture contains the concepts of the course entitled as Digital Electronics and Logic Design, having course code ECE 313D. Here are the concepts that I will discuss in this video. The first one is binary code. Actually, binary code is a group of bits used to represent data in digital systems. That data can be in the form of numbers, alphabets, or special characters. In this lecture, we are going to study these three codes. First is binary coded decimal, that is BCD. Second is XS3 code, and the third one is gray code. Now let us study the first one, that is binary coded decimal. This code encodes the decimal digits ranging from 0 to 9 into binary numbers. It's an example of weighted binary code because while encoding decimal into binary, it uses the concept of positional weights. BCD code is commonly known as 8421 BCD, where the bits from MSB to LSB have the weights 8, 4, 2 and 1 respectively. For example, here we have considered BCD of number 9, which is 1001. This is MSB, this is LSB. So the weight of this bit is 8, weight of this bit is 4, this bit has got a weight of 2, and this bit has a weight of 1. So BCD is a weighted binary code. It is a numeric code in which each digit of a decimal number is represented by 4-bit binary number. Like here we have considered decimal digits ranging from 0 to 9 and their respective BCD codes are given here. Now how to write BCD of a decimal number when there are more than 1 digits in a decimal number? The method is explained here. In that case, that is in multi-digit decimal number, each digit is individually represented by 4-bit binary number. Like in this example, we have to find the BCD of decimal number 58. So first of all, we will write down the 4-bit binary equivalent of this digit, that is 5, and after this we will write down the binary equivalent of this digit, that is 8. So these two numbers together will give BCD of decimal number 58. That means whenever you will find any decimal number having more than 1 digits, in that case you need to first of all represent each digit by 4-bit binary number, and the number formed by all the digits is later BCD of that number. This method will help you to find the BCD of any decimal number having any number of digits. BCD is less efficient than pure binary system because here in BCD more bits are used to encode a decimal number than pure binary code. But in spite of this disadvantage, it is very useful code and is used to encode numbers for output to numerical displays like LCD. This was all about BCD. Some review questions are given here which you may practice in order to understand BCD in more better way. Next is XS3 code. XS3 code is a modified version of BCD where XS3 code of a number can be obtained from BCD by adding 3 to each coded number. That means, for example, here in order to get the XS3 code of number 6, you have to first calculate the BCD code of number 6 and then you have to add plus 3 to that and the result will be XS3 code of 6. That is like here, XS3 code of 6 is equivalent to BCD code of 6 BCD code of 6 written first, then plus 3 is added in binary form, and this result is the accessory code of number 6. This method can help you to find the accessory code of any decimal digit. Here we have taken decimal digits ranging from 0 to 9, and their respective accessory codes are given here, which are calculated by adding 3 to their respective BCD codes. Now let us find the accessory code of number 645, that is a decimal number having 3 digits. In this case, first of all, we need to find the BCD code of 645. That means here we will represent first 6, 4 and 5 individually by their 4-bit binary representations. That is, 6 is represented by this, 4 is represented by this binary number, and 5 is represented by this binary number. So this overall forms the BCD code of number 645. Further, in order to get accessory code of this number, you need to add plus 3 to each digit. That is, plus 3 is added here, plus 3 here, plus 3 here, and the result obtained after the addition is the accessory code of number 645. This method can help you to find the accessory code of any decimal number having any number of digits. Further, some features of accessory code are given here. That is, accessory code is not a weighted code. It is a self-complementing code, which means that one's complement of the accessory coded number yields 9's complement of the number itself. And this property of accessory code helps in performing subtraction operations in digital systems. Next one is gray code. Gray code is a unique code. It belongs to a class of code known as minimum change code. In this code, decimal number is represented in binary form such that a gray coded number changes by only 1 bit as it proceeds from one number to the next. This statement means that in gray code, two consecutive numbers, that is like 6 and 7, 9 and 10, etc. These two consecutive numbers in gray code differ by only 1 bit. And hence this code is called as unit distance code. Further, gray code is also a reflected code, and it is used extensively for shaft position encoders. That is, where an analog quantity, that is shaft position, is converted in digital form. And gray code leads to reliable conversion because a small change in analog quantity changes the code by only 1 bit. Now next is you need to find gray code of a binary number, that is binary to gray code conversion. In this case, a binary number will be given and you have to calculate the binary code of the binary number by following these two steps. So let us consider this example, that is, here we need to convert 10110, this binary number, to gray code. First of all, first step is retain MSB of binary number in the gray code. Okay, MSB is retained. Second is going from left to right, add each adjacent pair of binary codes to get the next gray code bit using modulo 2 addition. Modulo 2 addition is that type of addition in which we retain only the sums and carries are discarded. Like here, after retaining MSB, we have to add the adjacent pair of binary codes to get the gray code. That is 10110 plus, we will get 1, 0 plus 1, 1, 1 plus 1, 0, carry 1 is discarded, 1 plus 0, 1. So this will give the gray code of this binary number. Next is you need to find the binary number of a gray code. So two steps are again given here. This is the gray code. It is 11101 and you need to find the binary code. First of all, retain MSB. Then going from left to right, add each binary code bit generated to the gray code bit in the next adjacent position using modulo 2 addition. This means that after retaining MSB, you have to add this MSB to the gray code bit which is next adjacent position. So it is 1 plus 1 0, discarding the carry. 0 plus 1 it is 1, 1 plus 0 it is 1, 1 plus 1 it is 0, carry discarded. So this is the binary code of the given gray code. Next, here we have given decimal numbers from 0 to 15. Their binary codes are given and their respective gray codes is also given. Some review questions are given here that you may practice in order to better understand these codes. So this was all about the binary codes. Hope this video will help you to understand the concepts of binary codes. Thank you.